Hey guys, Rob Skiba here. So this short video is going to be a continuation of where we left off on the video I put up last week called Atmospheric Lensing and the Chicago Skyline. So if you haven't seen that one yet, go ahead and stop this video, go find that one. I'll put a link in the description below. Watch that one first, and this one will pick up where we left off from there. Now this is a still frame from the half-hour video that I did, and the numbers you see there are all based on the numbers that Tony was giving me based on his device. His device said it was 37 nautical miles, which is 42.6 statute miles, but when you plot the same exact location that we were at, the exact distance you get on Google Earth is 46 miles. So you basically add about 4 miles to all the numbers that you saw in the half-hour video. But I'm beginning to think you don't even really need refraction. All you need is the atmospheric lensing. If that is indeed the science, and let's just go back and hear from the experts once again what's happening with the atmosphere.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
So the atmosphere really is acting like a lens.
Yes.
So the atmosphere really is acting like a lens, according to the experts. Now, you guys don't need to go out and spend tens of thousands of dollars to get that pretty piece of paper to hang up on the I Love Me wall and put letters after your name so that you can call yourself an expert. You can be an expert with what you see here on the screen. Yep, believe it or not. Go to Walmart, and your advanced degree in atmospheric lensing technology will cost you just a couple dollars. You can get a 2x power lens for about $1.85, I think, at Walmart. Get yourself some Scotch tape. Then if you look in the description below, you'll see I put a PNG file of a city. You can print that up, cut it out so it looks something like this, what you see on the screen here. Then find a table and a chair. And okay, you're going to bend the paper so it looks something like this. Tape the lens to the table. Get a chair that's about the same height as the edge of the table. Put your iPhone on the end of the chair, and the chair will act as a dolly, so you can just kind of pull the chair back. And looky here. Look what happens with atmospheric lensing. Wow, isn't that amazing? And you didn't have to go to college either. Now, you can get in a boat and drive to Chicago, and wow, look at that. Now let's compare. See, look at this. This is how much of the city was lost simply due to atmospheric lensing. Now remember, the experts, the guys that spent tens of thousands of dollars to get advanced degrees in this stuff so that people would recognize that they're smart, they told you the science really is that of a lens. But as I began to think about this more and more, okay, so with the lens you really don't even need refraction, but you may not even need the lensing either. Just go out into a field, something like this. This is a nice flat field out by my apartment complex. Lower your iPhone to the ground to simulate us, because we're really small on this massively large plane, right? Straight horizontal plane. Then go ahead and walk away from your camera on this flat horizontal plane. And just for the fun of it, let's go ahead and bring the city in here. And I'll try to keep my head right between those two buildings right there. And I'm going to pull the city along on this flat, straight, horizontal plane, pulling the city far away, and just simply due to perspective lines, look at what we end up with, boys and girls. Amazing, isn't it? Now let's bring the water line in to simulate water instead of grass and get rid of the background there with some sky. Now let's slide our little city over here. Put the big city back in, and well, just due to perspective lines, this is how much of the city magically disappeared. So based on what we've just seen here, apparently all you either need is lensing, refraction, or perspective lines. Either one or all three can easily account for the obscuring of the lower parts of cities and ships for that matter, with no need of curvature whatsoever. Oh, and just as sort of a bonus round, if perspective works for ships and for cities, I guess it would work the same for the sun too, so maybe this explains sunrise and sunset on the flat Earth. Works the same way. Perspective. Pretending my face is the sun, face like the sun. Little shout out to my friend Gons. There you go. It's not rocket science. Thanks so much for watching. I hope you enjoyed this video presentation. If you did, please subscribe to my YouTube channel, like the video, and share it on your favorite social media sites. There's a lot more to come, so stay tuned and we'll see you back next time.